Hello, how's everyone doing? This is Mr. Beaulieu. I just wanted to make a quick video showing you the basic idea of substitution. That's what you're working on this week on how to solve a system. So you actually don't have to graph it. If you don't have graphing technology, this works pretty well. When you're solving a system, what you're really looking for is you're looking for a certain x value. I'll identify the x's in both equations, and also a certain y value. I'll identify the y's in each, that you could substitute into both of these equations, the same thing for x and obviously the same thing for y, and it would make both of these equations true at the same time. That's what it means to solve a system. So let's actually solve this system using this idea of substitution. Let me just erase these arrows. So the basic idea with substitution is if you have an equation that has a variable isolated, like the first equation, the y is isolated, that's a good thing. You can substitute that in. You can substitute in 2x minus 3 for y at any given point. And the question is, well, why can you do that? Why are you allowed to substitute in 2x minus 3? And in this scenario, we are saying that 2x minus 3 equals y. That's what that equal sign means. Okay? So in this scenario, 2x minus 3 is the same thing as a y. So in the second equation, see how we have an equation with two variables? We're going to substitute 2x minus 3 in for y in the second equation. Why can we do that? Because the first equation says they're the same thing. Y is 2x minus 3. Y is 2x minus 3. See what I mean? These things are interchangeable. So let's do that in the second equation. Second equation, which reads x plus 3y equals 19, is now going to change. We're going to substitute in for that y to this, x plus 3. Now here's where I'm substituting in for y, and I'm going to use parentheses because there's two things for y. It's a 2x and a minus 3. 2x minus 3 equals 19. This equation that I just wrote is almost the same thing as the equation above it. We've just substituted in for y. Now we have an equation with only one variable. It only has x's in it. So I'm going to solve for x. X plus, well, we have to distribute the 3. 3 times 2x is 6x. 3 times negative 3 is negative 9, is 19. Combine like terms. 7x minus 9 equals 19. I'm going to actually add 9 to each side, but I'm running out of room, so I have to bring it over here. 7x equals 19 plus 9 is 28. And eventually you're going to get, divide each side by 7, x equals 4. But you're not done. You now have to find what the y value is. So if I go back to that, I thought I had my eraser up. If I go back to that original equation, which said, and you can use either of these equations, but the original does work a little bit better because y was already isolated. If I now take the fact that I know that x equals 4 and I put it back into the x in my original equation, it would read y equals 2 times 4 minus 3. Y equals 2 times 4 is 8. So 8 minus 3, y equals 5. The solution to this system has an x value of 4 and a y value of 5. So we write the solution as 4, 5, or that is the coordinate where the graphs would intersect. Let me show you one last thing. In Desmos, I went and I graphed these equations. Okay, your red line is y equals 2x minus 3, y-intercept at negative 3, slope of up 2 over 1, and the blue line is x plus 3y is 19. Where do they cross? Go figure. They cross at 4, 5. So that's a way to solve a system of equations by substitution. I don't mind you guys using the graph to check your answers. All right, good luck.